Alright, so, warm up. Describe the relationships between the inputs and outputs in each diagram. Some of what you're going to see up on this OneNote will not be in your foldable. And that is okay. So if it's not in your foldable, you're just going to follow along. We're going to use it to discuss a couple main points. So I'm seeing which ones are there. And then we'll come back to them. So, first one, describe the relationship. So, if I have, on this first one, an input of 1, the output came out as 1. Input was 2, the output was 4. 3 went in, 9 came out. 5 went in, 25 came out. What is the relationship between my input to my output? Mainly, what's happening here? You're timesing it by yourself. Very good. So our little thing here is if I use x to do it, it's like x squared. Your square. When you times something by itself, that's the exponent 2. So it means 5 to the second power means 5 times 5. So I have 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 5 times 5 is 25. So if I put 8 in, what would come out from my output? 64. And if the output was 81, what would have been my input? Good. Anything you notice about this first one? Is there more than one answer possible? If I put a number in, can more than one number come out? So if I put 2 in, can anything besides 4 come out? No. When I apply that rule, only 4 comes out, right? If I put 5 in, the only thing that could come out is 25. Well, let's look at the second one. I put blueberry in, and blue comes out. I put a lemon in, yellow comes out. I put apple in, and yellow comes out, red comes out, or something else could come out. What do you think is happening here? What's the relationship?
The colors of the fruits.
Okay, so colors the fruit. Is there more than one possible answer? Yeah. Blueberry, it just came out blue. The lemon was just yellow. But an apple could be yellow. It could be red. It could be, I think you said it. So we could have green. So then what would be over here that I would put in and it would come out green? But we already have an apple. Remember, it has to be a fruit because we said color of a fruit. Maybe we have a lime.
Isn't a lime just not really linear?
No different. So, could we have is there other things that we could have used? Yeah, there's other. We could have said like grapes. Grapes could have been green, but then we could add purple to it. So, what's the difference between these two that we just did? Besides that one was with, the rule was square in itself, the other one was color of fruit. What's the difference you notice between these two input outputs? What was the biggest difference between this one and this one? Okay? Okay. So on this one we had multiple outcomes. This one we had one outcome. There's one other thing I want us to notice.
One we get really fast and the other one takes a little bit longer.
Okay. That depends on the person. Some people would think one was slower, they might switch them around. You go right there. What would be the other thing that you notice? Just real quick when you look at the information, what do you notice is different between the two pieces of info?
The second one's kind of taking out information.
Okay. How about this one has numbers and this is words? Is that okay? Yeah, we can use those. For what we're going to learn, that is okay. Here's what I want you to do. Open up your foldable to vocabulary. So I'm going to make sure I open up mine. And we're going to talk about our vocabulary we need for this unit. The first thing says, ordered pairs. Remember, in math, we always put our ordered pairs as X then Y. Where's your... Huh? Oh, were you gone on Tuesday?
Yeah. He's first in here.
I'll give you the foldable, and then what we have to do is set your whole notebook up, okay? Sorry, I forgot you were gone Tuesday. Alright, so, first thing, ordered pairs can be used to show inputs, which is our X, and outputs, which are our Y. So when I have ordered pairs, and I tell you I have the ordered pairs 0, 1, 1, 2, 2, 4, we call all of our X's the inputs, and we call all of our Y components, those are our outputs. A relation, that's the next part on your foldable, you'll see, says a relation pairs inputs with outputs. So the job of a relation is it pairs the inputs with the outputs. It can be represented by ordered pairs or mapping diagram. Well, we need to know these because you have to be able to do both. And you have an example there on your picture. Ordered pairs, 0, 1, 1, 2, 2, 4. Or if I took these, I could write them as a mapping diagram. The input was my X's, 0, 1, 2, 0, 1, 2. Output, well, 0 went to 1, so 0 went to 1. 1 went to 2, 1 goes to 2, 2 goes to 4. Okay? So that's a mapping diagram. That's an ordered pairs. We will have to be doing some of this. All right, so in our vocabulary tab, we have this example. So play A and play B. Play A says input tickets. 1, and it comes out as 8. 2 goes in, 16 comes out. 3 goes in, 24 comes out. 4 goes in, 32 comes out. What do you think on this first one for each diagram? How many outputs does each have? So you're going to look at this. And then on B, it says tickets, 1 came in, 4 came out, 8 came out. I had 2 tickets, 8, 12, 16. 3, I had 12, 16, 20, 24. What I want you to do, don't write this down because we'll do this class. Turn and talk with your neighbor real quick on this. I want you to discuss number 1. For A, how many outputs does each input have? And then we're going to do the same thing for B. This should only take you a couple seconds. Turn and discuss with your neighbor. How many outputs does A have? How many outputs does B have?
It has 7.
Alright, so let's look at this because I want to make sure we don't misunderstand what the question's asking. A. In play A. How many outputs does each input have? So when they ask that, they don't say how many outputs are there. They're saying when I start with an input, like 1, how many outputs does that go to? When I take any of my inputs, how many answers are there? What do you think, Aiden?
1.
Yeah. So we're going to write that. Everyone can put in this. Put A for our play A. And we're going to say each input has 1 output. And if we look at that, if I put 1 in, the only answer that would come out is 8. If I put 2 in, the only output that would come out is 16. If 3 went in, the only thing out is 24. So if we did that, let's look at B though. On B, how many outputs does each input have? One of them has 2, you said? So there's 1, 2. One has 3, one has 4. So it's kind of varying, right? So we can say varies from 2 to 4 outputs. So right now we're seeing that the difference between the two is one of them has only one output for every input, and the other one, it varied. It might have had two outputs, or three possibilities, or four possibilities. Okay, let's look at the second question. A and B. So, describe the prices for the tickets for each play. How much did the tickets cost in play A? If I bought one ticket, it cost me $8. If I bought two tickets, it cost me $16. $3 cost me $24. 4 tickets cost me $32. How much did each ticket cost? How'd you get 8, Jordan? Because of math. How did you use math to get 8 then? You kind of just realize it. You kind of just realize that though. Haley, can you help out with it? Oh, so you went for the easy one. Since there's only one output, if 1 is 8, then it's 8, right? I could have looked for the rule. Each time I'm times in by 8. That was kind of the rule. 2 times 8 is 16. 3 times 8 is 24. I could have went backwards and just said my output divided by my input would have been my rule. 8 divided by 1 is 8. 16 divided by 2 is 8. Okay, what about B? I'm going to pause just so we don't get all the recording up. But I'm going to pause. I'm going to give you about 30 seconds. I want you to turn, really focus on your brain. Figure out, can you get the answer? How much did the tickets on play B cost? So what did we get? How much does the ticket cost? You go to B. Jordan, you got 4. So I know a ticket costs at least $4 because I bought one ticket that costs $4. Harrison, follow on. But it varied. Okay. So if I also look at here, Jordan, was it you that just said $4 to $8? My ticket price is going to vary. It varies between $4 to $8 per ticket. This one's probably like if you're going to a special arena. If you're up close, the tickets cost more. If you're farther back, they cost less. But I can see that if one costs 4, but one can also cost 8. 2 times 4 is 8. 2 times 6 is 12, but 2 times 8 is 16. 3 times 4 is 12. 3 times, that's going to be like a decimal to get to 16. 3 times a decimal is going to be 20. 3 times 8 gets me to 24. So my ticket prices on this one varies between 4 and 8. Third question. A person buys 4 tickets for each play. Can you determine the cost of all 8 tickets? We buy all 8 tickets. Person buys 4 tickets for each all 8 tickets. So a person buys 4 tickets to play A. So for play A, can I find out if I bought 4 tickets, what would be my bill? And if I bought 4 tickets to play B, can I find out my total bill? How much do you think it's going to cost? No, it wasn't our homework, it's in our vocabulary. No. We didn't have one. That's awesome, you did though. Alright. So, who can help solve this? How can I do A? How can I find the price for A? Yeah, we know play A, the cost per ticket was 8. So I'm going to say 4 times 8 is $32. So for me to buy 4 tickets to play A, yeah, I can find it. It cost me $32. What about play B? 28 to 32? Close. What's the ticket prices range of B? 4 to 8. So if I knew that, it'd be 4 tickets at $4. 4 times 4 is 16. Or the tickets could have been $8, which is 32. So on B, I can't find your exact price, but B, my total price is going to be between $16 to $32. I know it's going to be that because the lowest price for him on B is 4, the highest price is 8. So can I tell you, if Evan said, hey, I went to play B and I bought 4 tickets, do I know how much he spent? No. Not exact. I have a little range, but I don't have the exact answer. Make sure I don't skip something. Okay, good. So in example 2, do you guys have this one? Okay, this is not on yours, so pay attention up here. Evan, I need you facing forward next time I mark your planner, bud. Okay, Dylan, you're in the same boat. Next time I'm stopping because of you.
Why did you stop at me?
I am right now because you're laughing at when I just asked him to stop. Okay, here we go. List the ordered pairs for each mapping diagram. So you're going to notice these aren't in your foldable. It's okay. We're going to do them quick in here. I have A, and I have input output. This is a mapping diagram when they show you the A and the B. When I was to write it as ordered pairs, can anyone tell me one of the ordered pairs? 2, 6. So one of them is 2, 6. What's another one? The next one we would see 3, 9, 4, 12, and 1, 3. Okay? We want to put them in order as much as we can. How about on B?
0, 0.
Okay, so I see 0 to 0. Hold on, let's get this down. 0, 0. 2, 1. 2 goes to 1. 2 to negative 2. 4 to negative 3. Okay, you will have to be doing this. So you're seeing the way we're writing an ordered pair, X is your input, Y is your output. Let's look at this example. If I have a function machine, and I look at my inputs, Phoenix, Denver, Jefferson City, Juneau, Lincoln. Does anyone know what those are?
Capitals. Yeah.
They're capitals. So these are all capitals. Over here, Arizona came out, Colorado came out. What do you think these are? States. When I put Phoenix in, Arizona came out. When I went ahead and put Denver in, Colorado came out. What is the rule? What's going on here?
Whatever you put in for capital, you're going to get the state.
Good. Whatever I put in for my capital, the state, it comes out. Can I get more than one answer? When I put Phoenix in, will I get anything besides Arizona?
No.
If I put Denver in, what has to come out?
Colorado.
So if I go ahead and I put Jefferson City in, what's going to come out? Missouri. If I put Juneau in,
Alaska.
good. Didn't know if anyone knew that one. Alaska.
Studied the capitals.
And if I put in Lincoln,
Nebraska.
there you go. Okay, so just clarifying, if I put in one of these capital cities, could more than one answer come out?
No.
Is Jefferson City the capital of more than one state?
No.
No. So we're only talking about Jefferson, Missouri. Jefferson City, Missouri. How about this one? Input, Missouri, Kansas, Nebraska, Iowa, Alaska. Those are what?
States.
Still states. But what if I did this? I put in Missouri, and let's say, sure, Kansas City came out. What if Liberty came out? What if Lakes of Ozark? So I put Missouri in, and Kansas City came out. Liberty came out. Lakes of the Ozarks came out. What could be coming? What could be the little transition? What could be happening when I do my input? Kemper?
You're putting places in the first one. Like Missouri has all those places.
Good. Destination. I put in my state, and a destination comes out. That's perfect. That's actually correct. So do I only have one output that can come out? If I look at Kansas, Topeka might come out. Lawrence. So on this function, when we put in one of the states, we have multiple answers that can come out. Okay, here's an important thing I'm going to have you do. In your notebook, we should have that orange page. It should come right before your foldable. No, I got to hand this to you, buddy. Alright. Here's what we need to do now. This is important for what we're doing. We have to define a function. So I made sure I wrote down my function I want us to use. Okay. I'm going to type it, to be honest. Okay, I want you to do this on your paper. Definition of a function. A function is where each, I'll make it bigger. This goes on that orange page.
Yeah, function.
Okay. A function is where each input has one and only one output. Get this writing in your notebook.
Right with your mind.
Huh? So I'm going to give you a second. I'm going to pause this. I'm going to give you just a couple seconds to fill this out.
Sure, it's always just
So, characteristics of a function. There's three things that we're going to talk about. This is going to be the pencil test. So, when we're checking to see if something is a function or not, a graph, we use a pencil test. Here's my graph, and it goes on forever. And I'm going to have this line in here. Let's just put it like that. Okay, what I do is when I do a pencil test, I take my pencil and I go vertical. You can see my shadow. And I work left to right to see, does it only cross that line at one point at a time? So when I come around, I'm seeing that, no, that I am only hitting my line at once when I'm going across this purple line. It's only crossing that purple line at one spot. If it does that, this is a function. So you should be writing this under your characteristics, and you can kind of draw on this. We'll do another one. When I look at this line, and I do the pencil test. Yes, I want you drawing this in on yours. When I do the pencil test on this one, I'm going to see when I do my shadow across it, I'm going to see when it hits this point, it's also going to hit that point below. So it's hitting 2 points on this line at the exact same time. Because of that, we say this is not a function. Based off what we have done now, we're going to go back and see, can you guys identify, you can face in front, Evan. I can find a new spot for you if need be. Okay. You turn over there and I'm talking to you. Why don't you stay after? I'll talk with you. Because now it's just a big joke. Okay. So, when we look at this, this is how you're going to identify whether something's a function or not. One, and only one output for each input. So an input has only one output. And if I look at the graph, we can use the pencil test. If we look at example 3, I don't feel you have this in your notebook, which is okay. If I look at this, it says input, -9 to 0, -2 to 5, -5 to 10, -12 to 10. Is this a function or not a function? What do you feel? Does it have, each input has one and only one output? Does any of the inputs have more than one output?
Yes.
Which one has more than one output? Yep, on A.
Oh, I was looking at it.
Huh? 10? Well, 10 is an output and it shares it with 2 inputs. But does one of my inputs go to 2 different outputs? So would this be a function?
No.
This is a function. Each input only goes to one other number. -9 only went to 0. -2 only to 5. 5 only to 10. 12 only to 10. The input only went to one output. If we look at B, is this a function or not a function? Ooh, you guys got that right away. Why is it not a function? Raise your hand if you can tell us why. Why is this not a function, Dusty?
Because the input, one input goes to more than one.
Which one?
0.
Good. 0 went to 5 and it went to 6. It went to 2 numbers. My input went to 2 different outputs. It is not a function. Let's scroll back up then. Is this one a function or not a function?
That would be not a function.
Why is it not a function?
Because there's multiple outputs for the
Yeah.
input.
We put in Missouri, we got a lot of things out. We put Kansas in, we got multiple responses. So, not a function. How about our capital and state? It's a function. Capital went in, only one answer could come out. So it is a function. How about A? 1 to 3, 2 to 6, 3 to 9, 4 to 12. function. How about B?
Not
You can tell me why. Raise your hand. Why is this not a function? All right, Harrison?
It has more than one output.
Good. Which one?
2 and 3.
Yeah. 2 went to 1 and -2. It's not a function. Scroll up to our first example. Which one of these is a function? A is. Good. Function. And B is not a function. Alright, we're going to do two things for the rest of our time. Write down these two.
Yeah.
We're going to do those kind of as a warm-up tomorrow. We were going to do it today, but because of time, we're not. Here's what I want you to do. I'm going to hand out these papers. Okay, you're going to have kind of two parts that we're going to do. With the rest of your time, the first thing you're going to have to do is when I give you these, I want to make sure you're paying close attention so you're doing this right. I'm going to move mine a little bit. Okay. In our notebook, we had this page. Function, characteristics of a function. When I give you, I'm going to come around in the rest of the class, we're going to do two things. I'm going to give you this sheet. You're going to cut out the part that says function. And you're going to cut out the one that says not a function. I'm going to go ahead and just split my paper then. And if you don't have room on this one, just go to your very next blank page. It's okay. But on here, we have example after example after example. We're going to cut all these out and we're going to sort them. And we're going to cut them out and glue them in. Where do they go under function, not a function? That's the first thing we're going to do. That's one part of your homework. The other part that I will grade, because we're just going to work, we're not going to have time to go over this. Your second part for your homework is this. Oops, you got to get to this part. Right here on your homework. We put this in there. 7.1 is definitely your homework. 7.1, there's only 1, 2, 3 things that you have to do. I am grading 7.1. I want you to do the card sort now, but 7.1 is your homework. Good? Read the instructions on the set. There's ordered pairs. So you take those and add those ordered pairs. No, I'm going to come over and help you out. Just a second.
2 minutes ago.
Yeah.
Oh.
You have links down, don't you? So, yep, we're gluing these in. Okay, once again, making sure you understand. Homework, due by tomorrow. It's a completion grade. 7.1, the first one, list ordered pairs shown in the mapping diagrams. So on this one, you have to tell me what are the ordered pairs, and then is this one a function? So you'd write function, not a function. They have a second picture. Is this, you have to list out the ordered pairs. Is it a function or not a function? Describe the relationship between the inputs and outputs in the diagram. Mainly you're telling us what was the rule. Okay, we did times by 2 or capitals to states. Then complete the diagram. So there's 2 blanks on this. Is there more than one possible answer? And then the last one, you be the teacher, you're going to have to look at what happened and explain. Very short homework assignment.
So, and then on the sheet, you just have